1, 2, 3. You guys. Okay, I did 1 through 4 just because it was easier that way, because you guys had 1 through 4, but the only evens were 2 and 4. 2, our cosine is cosine inverse, goes between, no, has a domain between what can plug in, -1 to 1, and what comes out, 0 to pi. Can anybody think of why I had you write 1, 2, 3, even though they were directly out of the notes? Yeah, maybe practice, maybe to memorize, and to have it written for the rest of your homework. Maybe you could refer back to it. Okay, number 4. Did you guys get inverse?
Yeah.
Nice. Number 10. Pi over 4 was the only legal answer. Pi over 4 was the only legal answer. Number 16. Pi over 4 also? Yep. Because at pi over 4, sine is 2 over 2, and at pi over 4, tangent is 1. Good so far? Nice. Number 40. Ooh, did you guys get them all? Our cosine of -1 would be at pi.
I don't know how we could figure that out, to be honest.
Remember? Unit circle. You have to ask yourself the question, when is cosine -1? Well, when the x is -1. And when is the x -1? Remember? Or,
I don't see how it relates, to be honest.
that's sine, right? Cosine goes backwards. When is cosine 1? 0, right? But if I need a -1, and if cosine is the x is going to be -1 only at pi. Everywhere else is going to be negative a little bit less or a little bit more, or it's going to be a +1 or a positive root 3 over 2 or root 2 over 2 over 1/2. Only here is at -1. And remember, cosine is allowed to go in between 0 and pi. So we're not looking down here, but the only location for cosine to be -1 is at pi. The only location for cosine to be -1/2, when is cosine 1/2? 60. But if it's -1/2, do I want 60 or do I want its counterpart in the second quadrant? Yeah, remember cosine goes in between here and here. So I don't want positive, because that would give me a positive 1/2. I want negative, hence why 2 pi over 3 is the location for negative. And then last but not least, cosine of pi over 6 is root 3 over 2. Dun, 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 dun. Okay, was it just the top one that was real?
I didn't know how to figure them out, honestly. I just saw it and I was like, yeah, that looks like...
Does it make sense for going backwards,
Yeah.
though? So it's kind of like you just have to know really well to say, okay, when is the answer -1/2 in between 0 pi? You have to go backwards. So in the table, like you can kind of think of what I did in the sense of when is cosine 1/2? 60, but I need second quadrant because it needs to be a negative. Does that make sense? Kind of same thing with here. When is cosine 1? 0. But I need the second quadrant counterpart. I need over here to be the negatives.
And I keep getting messed up in... Okay, when I see our cosine of -1,
Yeah.
I still apply the cosine rules like quadrant 1 and 2, right?
Yeah. Because arc cosine is cosine inverse, and they both have the same rules from up above of you only being allowed to look in between 0 pi. Does that make sense? Because remember, these two guys, they're synonyms. They're the same thing, just alternate ways of writing. Okay, number 52. What? Why isn't it just cross-cross? Why is it something different? I have to do the legal one, right? So if you were to do 7 pi over 2, did you guys figure out is at the same place as pi over 2? Remember? Because from yesterday, you can't just cross-cross. Yeah, he's too big. But who is he? He's 3.5. So 3.5, I go 1, I go 2, I go 3 pi, and a half pi. But am I allowed to be down there? So I have to do, oh, yeah, I have to do the counterpart in the legal, so I have to go up there. So I have to go up there. This one was a little bit weirder. It didn't land perfectly on one that we wanted. It actually landed here at 3 pi over 2. The question, at what point is cosine going to be the same? Over here. Because down here I have 0, negative 1, cosine is 0. Up here I have 0, 1, cosine is 0. So I can just steal his counterpart. Okay? Number 66. Ooh, he was one of those build your triangle, right? Oh, did you really? Oh, let's go find him. I just didn't even think about him. 54. Where are you? Oh my goodness, this is taking forever. Oh, passed him.
There he is.
There he is. Oh, he is with numbers. Yeah, that makes sense. I'd start with numbers first, huh? Okay, you have to build your triangle. Did you guys end up with 5/3?
Yeah.
You'll get him in here so I have him for next time. 54 should go right here. There we go. All right. Now number 66.
How do you give a plus?
Oh, a positive? Because as you're looking at number 54, they say in the first quadrant.
Oh no, in 66.
Oh, sorry.
Because they give you an angle X. You don't know which quadrant that is, so I put plus or minus.
Oh, they didn't give you any clues? Yeah, I put plus or minus 2. Did they give you no clues on this one? Did anybody else put plus minus because you couldn't tell? Yeah. I would have put plus minus also. They're probably just saying, like this is the basic formula, so they just made it positive, but we know it could have been plus or minus. Yeah, I agree with you. You did the best answer. Did it work out okay? If you guys tried to rationalize, it would have been okay, but this one you're just trying to make a formula, so it's okay since it's not an answer to not multiply top and bottom by the square root. Hence why they just left it in this form right here. Number 78. Did I get the wrong one? Oh, it is. What was the question? There's your triangle. The triangle makes sense. What were you supposed to be doing? Oh, you did like fill in the extra part. Oh, okay. So what they did is this is the one given to you though, right? Okay. So they took this and made a triangle out of it, right? That's your opposite. That's your hypotenuse. And then they figured out who must be the other side. You can actually kind of see him right there, can't you? A little bit. So they kind of like gave you the answer and you had to figure out the question. But you could have also used Pythagorean. You could have made him an unknown. Him squared plus him squared is that squared, and then you could have solved it. It would have worked out. So the final answer is this, right? X over 6. I wasn't sure where to point you for the answer. Thanks, guys. And then 108. I think he's our last one, right? 108. How do you get theta alone? How do you undo a tangent? To use the inverse. So you can say arctan of this side cancels arctan of this side. There we go. Or you could have said tangent inverse. That would have also been fine. And then down below for letter B, they gave you some information. You were trying to plug and chug. They gave you 7 miles. You could plug it in your little formula, and then you could get in radians or degrees, in radians or degrees. I guess they didn't tell you which one it was. Are we okay? This is for 7. Was there anything else, especially in the odds, that we need to quickly peek at? You're like, I had no clue. Maybe a couple? As we do that, if you guys have a book with you, I would get it out on your desk. We're going to do a couple more examples from 4-8, but remember we're going to kind of work on 4-8 together in our groups so that we're not like alone doing it by ourselves. If you guys have books in your locker, you can run and grab them now as I'm looking at any questions that we have. Or if you need to borrow one from up here, I have 1, 2, 3. Oh, did anybody find any questions on 4-7? Okay. Don't get lost again. Alright. So no more questions on homework. Let me get rid of him. Yeah.
So did you find my test? Because I saw it wasn't on Red Lab yet. And
Was it a test correction?
no, I didn't need to. You just told me to
Oh, yes, I did.
and it comes up.
Yes, I did.
Okay.
It was in your folder. I was double checking.
Okay.
Is this another example? Let's do it. Yeah, because in the back, in the back, you can go. Yeah.
Alright, kiddos, I have like basically two examples, and then we're just gonna work. So example number one, it's already up on the board, so you're still in your notes, but we're going to 4-8 really quickly, okay? Example number one, up on the board. I wanna see if you guys can work as a group to draw a picture from. Work as a group to draw a picture, and then we'll solve it all together. So let's see if we can work as a group to draw a picture of that situation. We're still in our notes for just like two more examples. You guys are then ready to go ahead and bust out that 4-8 as much as possible together. But first, can you draw a picture for this one where there are only words? Approaching means coming towards or away? Uh-huh. It's already up, it's flying straight. Yeah, it's a little rough. That's why I want to do this one all together.
How are you gonna get a distance?
Because it tells you 1 minute.
After 1 minute.
So if you use the speed and you use the time, you can find the distance.
Oh boy, I see. Build bridges. This is
Where's the plane for you guys? Is he on the left or is he on the right?
left.
I put him on the left.
So you're over here. And here's Mr. Airplane. Okay, there you go. Mr. Airplane, he's coming. Yeah?
Yeah.
And he's flying straight. I'm just gonna go ahead and give him like a line of sight. You guys know what I'm talking about? Like it's like his path.
Oh, yeah.
Okay. Because he's approaching, he's coming towards you. He's technically coming this direction. So there's a line from you to the plane. What is that first angle? 16 degrees. Oh, I need to put the ground too. Huh?
But it's an angle of elevation. Oh, it's still fine. It's the same.
And then it says 1 minute later, the angle all of a sudden, why would the angle be way higher? Because now if he's over here, right? If that's him, isn't it natural the angle's going to be higher? Okay, now that was a hard picture. I think it's a hard picture. Right? Because the plane is like moving, and so at one time he's in one place with one angle to you, and then another time he's closer, so he's at another angle to you. Okay. What are they asking?
The altitude.
What's that? How high? The opposite. We need to make ourselves some triangles, yeah? Ooh, how many different triangles do we have? Mm-hmm. But the altitudes are the same because it's the same plane on the same flight path. And we're saying he's not descending, he's not landing, he's not ascending, he's not going off the runway, he's just flying. And we're just watching him as he goes.
But you can only find the distance of the triangle at the 57 degrees.
I know, so what's missing? What do we want to know?
The adjacent.
We really want to know, the adjacent or the hypotenuse. Do they tell us anything about the distance from us to the plane?
No.
But what do they tell us about how fast he's going? He's going 550 miles per hour, but can I label this 550? No. That's not how far. I can use distance equals rate times time, but wait, what time do I have? How long was he flying? Okay. So distance equals rate times time, but hours and minutes aren't going to cut it for me. So we either change the minute to hours or the hours to minutes. Which one makes more sense?
Hours to minutes.
Yeah, I think so too. Let's go ahead and take our rate and say you're good at all, but I need you in minutes instead. So I have miles per hour. What am I going to multiply by? Yeah, because I want minutes up top, right? So we can do 60 minutes.
No, we need it.
So it's 1 over 60, right? So we have 1 hour. There we go. Now do my hours cancel? Perfect. So I can say 550 over 60. Well, the zeros reduce. 55 over 6, that doesn't really go any further, so we'll just stop there. Miles per minute. Well, wait a minute. Hold on. If we know it goes that fast, that many miles per minute, and it says that it flies for how long between the two angles? 1 minute. Well, how many miles did it go? 55. Oh.
That's only between the axis.
But can you tell what that labels?
Yeah, only that. I don't know.
Oh, 55 over 6. I didn't put over 6. Because he travels 55 over 6 miles. Sorry. Is that better? So does that make a side of any triangle?
It makes half.
But how do we make the triangle? Well, you better call the other side something else.
Why?
But wait, you guys willing to go out on a limb just a little bit?
Tangent of 60 plus x over 55 over 6 plus 1.
Let's do it step by step. Tangent of 16 equals who? X over
55 over 6 plus 1.
That's an equation, because I need that whole side for the 16. I need to see it, I can go ahead and show. I need that whole side, the 55 over 6 and the 1. Sean?
Okay, so then could we set up a triangle, solve for x and then substitute? Or solve for y and substitute?
Just because we're trying to find x, I would say solve for y to get rid of 1. So let's make another equation. This is the blue one, right? Now we need one for the green one. What's he going to be? Tangent of, who's the other angle? Equals x over just y, right? He only needs that little part. 2 equations, 2 unknowns, completely mathematically possible if we can just solve for one and plug into the other.
Is there any possible way that we can find how far, and how long the plane would be, like, over your head? Because that's why.
Well, over your head, it's going to fly and it's going to have the same height though, right? If it
Yeah,
keeps
but
lying.
at least you would know why. Like, how long would it take? Or like,
So Luke is like, why don't we figure out, but you don't know how far away it is. So you'd still
Yeah,
have to
but-
figure this out to know how far it needs to go to get over your head. So what we're doing could figure out how far, and that could tell you how long until it's overhead, but I don't know if you could go the other way.
yeah,
I don't know if we have enough information.
you know.
Yeah, I like that one. And Sean and I were talking about this. Karina, can you explain it again? Why did you solve for y? Why is that a good idea?
Because you have like the y by itself in the equation.
Yeah, you can plug it in. And who do we want to stay in the equation because we want to solve for? X. So we're keeping the x's and we're keeping things in terms of x. Maybe a better way of putting it. So we can solve for y. We can plug in over here now. It's not pretty. Totally agree. But what could make it a little easier? Can someone give me a decimal for 55 over 6? That's kind of messy, right? Maybe we'll make that a number to make things a little bit easier. 9.166. So 9.1. I'm going to do a few more decimals than normal, right? Because we're not done yet. And then let's do plus. We have x times tangent of 57. Okay. Some of you would be scared of this, but don't be scared. Just think mathematically.
X over.
It's X over tangent
It's
fifty
X over.
because of the switch.
What did I do?
You didn't do all the steps.
I didn't do all the steps. I pointed out the common error that I see time and time again. But good catching it, my ones that did do the steps. You would need to multiply by y and then divide, right? Now are we legal? Nice.
You can just.
I made a jump and I didn't think about the legal steps. So the legal steps, you'd have to multiply by y.
Oh, and then divide.
Exactly. But our brain doesn't always do that, so we have to kind of walk it through. If your brain makes the common mistake I just showed, show your work. So we multiply by y's. Hopefully then you see y's divided. Okay, good. Now it's even more daunting. A question, what does math tell us to do when we see a division and we have to move stuff, simplify stuff, solve stuff? Yeah. So we're going to move this guy up. No, wait. Let's do it. Move him up. Move him up. I'm going to have tangent of 16. Guys, why am I not plugging tangent of 16 into my calculator and getting a decimal? So we can have it more accurate and not have to write lots more decimals. Okay, so 9.1666666.
Don't you distribute?
We have a few options. What do you think?
Distribute.
Yeah, we can distribute. I know, but as long as we keep it legal, we're okay, yeah?
Is that gonna be the answer for X?
We're gonna have to use it for the answer for x. And x is on both sides.
Put minus.
Yeah. Combine like terms. Move that x term over this x term. Right? Come on, don't let the math scare you. Gotta keep it legal. Okay, I'll show work. It's rough, but we're getting there. This is why we don't have so many problems. Yeah. How do we? Couldn't you in your calculator do 1 minus that number and get a new coefficient?
Yeah.
That works. Or couldn't you just pull an x out?
Yeah, we can do that too.
Both ways work. You're gonna have to put it in your calculator eventually. But some of you might just want to be like, whatever, I'll get the math and I'll put it in my calculator later. If some of you want to go back to that nice 55 over 6 to make it perfect, you can. You don't have to. But how do we get x alone? Woo! Good thing we get to use a calculator. We don't have to mental math this one that we wouldn't be able to anyway, because it's not unit circle. We finally have x alone. And over here, we have a big old mess we're going to put into our calculator. But do you guys remember that cool little fraction-y function that makes it look all pretty and in a nice fraction? Yeah, alpha y equals enter. Just to show some of you guys that tend to like put things in and then even though you're putting it in right, the calculator gets it wrong. Let's walk through really quickly how to put it in. Oh man, guys, we might just stop at that one. That was a little rough, huh? Just a little bit. I'm not plugging in chugging, I was just going to show you how to put it as a nice fraction. Let me peek really quickly at what problems I actually gave you for homework. But we're at the end though, right? Come on. Okay. What was I talking about? Remember the nice little y equals? Couldn't you put a little fraction? And couldn't you technically put a little fraction in a fraction? Ooh, that's nice. You could do like a little 55 over 6. Yeah? What mode should you be in? Yeah.
How did you do that, Misty?
Here, I'll show you again because we do a fraction. You ready? 1 minus. Do alpha. See, alpha button. Y equals. The n over d means a little baby fraction. Just hit enter. Boop. Oh, look. There he is. Tangent 16. Now, if you have one of those old ones, sorry, Sean, you have to use lots of parentheses.
It's good, I got it.
But he got it. He's got it. I'm probably in radians. Am I in radians? I am in radians. Ignore my answer. What'd you guys get?
Whoa.
It shouldn't be my answer. Remember, I was in radians. 3.229966363. Double check. Ooh, check your mode. Are you in degrees? Oh. 55 over 6, tangent 16. Do you find it? All right, kiddos, that's our final answer. We just need to go ahead and write it, 3.229, 3.230, right?
Yeah. So around it,
Yeah.
What I'm typing, my calculator is okay to
I
do.
got 6.
Nope, it was 230, right?
Yeah. 3.2.
Kilometers? Meters? Miles.
Oh,
Oh, yeah.
I see what I did.
Oh, for the next part. Do I need to do for the top two or just the one?
We have to do it when there's adding and subtracting. So the top is adding.
Is there gonna be one like this on the test?
Is it anything on the top?
It'll probably be a little bit more like that.
So that was.
This one you had a piece of information and you saw. This one was an adventure. Adventure is a wonderful thing. Okay. Ready? Section 4.8. Oh, did you guys see the Google illustration today?
No.
For a famous scientist, physicist, he was all sorts of things. Do you see what's in the background?
Oh, a sign.
What? It's a sinusoidal curve. Super exciting. Anyway, you can go read about him. He's the Google illustration for the day. Section 4.8. If I were you, open up book. Spiral. Get the assignment down if you have not yet already. But I'm peeking to see if I want to take off anything. Oh, what? Not the entire thing, but. I am going to take off some.
Sorry.
The whole thing? You did You did bearings? What number did you start at? not gonna think of
I said one.
Just extra credits are always.
I'm gonna take off the last 4.
Yeah.
No, it's not Friday. It's Friday. That's crazy.
Wow, that was cool.
Okay, but there is one more quick thing. Hold on, there's one more quick thing we have to look at because it starts in homework number 37, so it's only at the end. These 3 need us to talk about one quick thing, okay?
Okay.
Sorry, I'm taking away your time, but it's gonna make it easier. But I took away 4 problems. Does that count for something?
Yeah.
So then coming back. You're gonna see a word, and I need you to know what that word means. Now, you don't need to stress. If you wanna write this down, yeah, maybe you should write down. All it does is changes how you look at the picture and how you measure this angle. Now, the nice thing is, I'm gonna tell you right now, bearing's not on the test. Okay? Bearing's not on the test, but it is super important in physics. So I just wanna show you what it means. You have like 3 problems that use bearings. Do your best on them, but don't stress. Are we tracking?
Yeah.
Okay. So bearing's not on the test. Do your best on these few you see tonight. But don't stress. So I kind of took away 7 problems, 4 totally, and 3 you just don't need to stress about. And maybe we'll just peek at them quickly tomorrow. Bearing is a special way of measuring angles when we're doing angles in navigation. Because navigation, you're on the sea long time ago. No instruments, no phones, no GPS locators. What's the only thing you have to measure by?
Compass.
You have a compass, but you have to start that compass from somewhere. Where's that compass? Where is it, in some senses, where is it aligned to? Where does it measure from?
North.
Measures from north. Why? North Pole, but you can't see the North Pole if you're on the ocean, but what can you see? The North Star. You can measure from the North Star. Okay, so here's how bearings work. If we're measuring a standard angle, just an old-fashioned angle, don't we start from east if we were thinking like the compass?
Yeah.
A normal angle would start from east. Well, that's awkward. There's no east star, right? So then, instead of measuring standard position, bearing starts north. A compass bearing starts north. Now, technically, there are other ways. If you have other little directions, it can kind of help as well. A normal bearing, though, instead of doing the standard position, a normal bearing, a compass bearing is what we talk or refer to it as, starts from north and goes clockwise. So you're just gonna have to change your reference system and say, oh wait, this is a bearing. I don't start from east, I'm gonna start from north and go this way. So it kind of changes everything. That's why I don't want it on the test. I don't want it to like totally confuse what you know about angles. But I do want you to be able to understand if you see something like this. Now hold on, what's that talking about? Some angles, it might be easier to start from south. And if you're doing south 35 degrees east, question, start from south, and what way do you think you're rotating? Towards east. There's your angle. If it doesn't give any direction, you automatically think north down. But if it gives something else, you start from south and go towards east, or start from north and go towards west, or start from north and head east. Does that make sense? So it's useful in navigation. It's one of those things like when you actually start needing to work with angles in like a practical setting, it'll probably be navigation. And this would be important to understand as to how we put the angles and how it relates to like the world as a whole, with north, south, east, west, the poles, the north star, etc. Okay, anyway, sorry, I'm done. You guys have homework written down. And one more quick time, just to peek at it, wherever he is. These 4 gone. I'm gonna erase them as soon as you guys leave. These 3, no stress for the test. Let's see how you do last night with them. Tonight. Sound good? Alright, go team. You guys have 25 seconds. Hang out, enjoy it. If you borrowed a book, please give it back to me now, so that I don't go losing expensive but very beat up books. I know, the worst ones are the ones I have, huh? Alright, kids. Enjoy nutrition, enjoy your Wednesday. Answer.
Congratulations.
No, you're
Why not number 1 though? Because you're not on the team.
Thanks, guys.
Whoa, dang. Compliment was.
I'm just gonna save this video. Come on over.
I love you, but.
Okay, bye.